If you bought a Samsung washing machine in the last 3 years, there is a 1 in 4 chance it has already failed or is failing right now. If you bought an LG, reliability data suggests the odds may be comparable. And if you bought a Whirlpool, a Maytag, or an Amana, you bought the same machine with a different badge, running the same control board, failing the same way, on the same timeline. This is not bad luck. This is not user error, and it is not a manufacturing defect in the traditional sense. What you are watching is the systematic replacement of durable mechanical appliances with moisture-sensitive electronics that were never designed to survive the environment they are installed in, dressed up in a Wi-Fi connection and sold to you at a 30% premium. In this investigation, we are going to expose the specific component that is killing your washing machine, the corporate decisions that put it there, and the repair system designed to make sure you never fix it. We are going to name the part, name the failure mode, name the companies, and name the dollars. And by the end, you will understand exactly why your grandfather's washer ran for 20 years, and yours will not survive its third. Let us start with how we got here. Before 2008, the washing machine was one of the most reliable appliances ever built. The control mechanism was a mechanical timer, a small assembly of metal gears and springs that clicked through a cycle the same way it had since Eisenhower was president. The water level was detected by a mechanical float inside a pressure chamber. If the float failed, you bought a $4 part and replaced it in 20 minutes. The motor was a permanent split capacitor induction motor, heavy, inefficient by modern standards, and nearly indestructible. Repair technicians who worked through the 70s and 80s will tell you the same thing. You replace the belt, you replace the pump, you replace the lid switch. The machine itself lasted 15 to 25 years without question. Then two things happened almost simultaneously, and together they destroyed the appliance industry. The first was the Department of Energy's 2012 efficiency mandate under 10 CFR Part 430. The rule forced manufacturers to meet stricter water factor and energy factor targets for residential clothes washers. To hit those targets, manufacturers switched to inverter-driven brushless DC motors and sensor-based water management. They called it smart cycle technology. We call it the regulatory backdoor to planned obsolescence. Because to run a brushless DC motor and manage variable water levels, you need electronics. Sophisticated electronics. Electronics that do not belong in a humidity-saturated laundry room. The second was corporate consolidation. Whirlpool acquired Maytag in 2006 for approximately $2.6 billion, including assumed debt. They did not buy Maytag to build better washing machines. They bought it to eliminate a competitor, harvest the brand equity, and rationalize costs across a unified platform. Within a decade, the flagship Maytag, the brand whose commercials ran for 30 years on the premise that the repairman had nothing to do, was sharing a control platform with a $500 Amana. The same failure mode, different badge, different price point, same landfill timeline. Samsung and LG were running a parallel operation. After 2016, both companies pushed hard into what they called the smart home ecosystem. Wi-Fi-enabled washers, app integration, remote diagnostics. In Samsung's case, the IoT push was explicitly tied to appliance margin targets. Their earnings reports show appliance margins climbing above 15% post-IoT. They achieve that margin increase the same way every manufacturer achieves it, by removing durable mechanical components and replacing them with cheap electronics that command a marketing premium. They call this value engineering. We call it the great cheapening. And the business model is only half the problem. The materials themselves have been engineered to fail, and the specific mechanism of that failure is something you need to understand exactly. The component that is killing your washing machine is called the Central Control Unit, or CCU. In a Samsung machine, the model number is the DC92-01622A series. In an LG machine, it is the EBR series board. In a Whirlpool or Maytag, it is a shared platform unit that runs across every brand in that family. The CCU is a multi-layer printed circuit board covered in surface mount components. Capacitors, resistors, voltage regulators, all soldered onto the board using a process designed for consumer electronics, not appliances. It integrates the Wi-Fi module, the inverter drive for the motor, and the inputs from every sensor in the machine. It sits behind the back or top panel, near the wiring harness, in a machine that produces humidity, vibration, and temperature swings with every single cycle. Independent teardown analysis of machines like the Samsung AdWash and comparable LG washers has consistently returned low repairability assessments. What those teardowns find is that the sensors, the load sensor, the water level sensor, the fabric detection sensor, are sealed into the tub base and drum assembly. There is no individual replacement pathway. If a single capacitive sensor fails, you are not buying a sensor, you are buying a board. Now let us talk about how the CCU fails, because the failure mode is specific and it is predictable. The solder joints on a surface mount circuit board are vulnerable to two things: moisture and thermal cycling. In a washing machine, you have both every day for years. When the machine runs a hot cycle and then cools, the board expands and contracts. The solder joints, already microscopic, develop micro cracks over time. Simultaneously, the humid air inside the cabinet condenses on the board surface. The epoxy coating that manufacturers apply is not a hermetic seal. It is a moisture barrier that degrades. Consumer Reports surveyed members on their experiences with nearly 75,000 washing machines purchased between 2014 and 2024. And found that Samsung machines showed meaningful rates of major failure within the first 5 years of ownership. By year 5, failure rates across the smart washer category climbed to 40 to 50%. The machine does not announce the failure clearly. It starts with error codes. On Samsung, you see 4E, a water supply error indicating the machine is not receiving adequate water flow. On LG, you see UE, an imbalance error. The machine throws the code and stops the cycle. You restart it. It runs. 2 weeks later, it throws the code again. Then you start getting a burning smell from behind the panel during the spin cycle. Then one day, you press start and nothing happens. The app on your phone cannot connect to the machine. The board is dead. The machine is 28 months old. This is not a fringe scenario. This is the Consumer Reports data. This is the CPSC complaint database. Samsung has accumulated multiple major recalls involving washing machines since 2016. A 2016 recall alone covered 2.8 million Samsung top-load units, flagged for a mechanical hazard in which the top of the machine could detach during operation. A subsequent recall in 2023, CPSC Recall 23-080, covered over 600,000 Samsung top-load units for a fire and short-circuit hazard. These are not quality control slips. This is a design architecture that was never safe for residential use at scale, and the sensor calibration problem compounds the board failure. The capacitive sensors that replace the old mechanical float, the dumb, reliable $4 float, are rated for 18 to 36 months of consistent calibration accuracy in high humidity environments. After that, they drift. The machine begins to read load weights incorrectly. It overfills or underfills. It throws imbalance errors on balanced loads. It runs extended cycles on light loads because the soil sensor cannot distinguish between a lightly soiled shirt and a moderately soiled one. Every one of these errors routes back to the CCU. Every one of these repairs routes back to a board replacement. Your grandfather's Maytag ran for 22 years on a mechanical timer that cost $4 to replace and a float switch that cost $6. Your machine will be declared uneconomical to repair before its 4th birthday. But the real crime is not the engineering. It is what happens when you try to get it fixed. The warranty on a new smart washing machine is 1 year. Some manufacturers offer a limited parts warranty of 3 to 5 years, but labor is excluded. That means if your CCU fails at month 25, which is squarely inside the peak failure window, you are buying a board and you are buying the labor separately. The board replacement purchased through the manufacturer runs $150 to $250 for the part alone. Labor runs $100 to $250 depending on your market. You are looking at $300 to $600 to repair a machine you paid $800 to $1,500 for. Here is where the trap closes. The repair technician pulls up the diagnostic code. He needs to access the Samsung SmartThings diagnostic system or the LG proprietary code library to identify which component on the board failed. Samsung has moved toward charging for diagnostic access. LG's failure codes are proprietary. Independent technicians are guessing, trying parts in sequence until something works. This is called parts canon repair, and you are paying for every shot. The technician's honest recommendation, 80% of the time, according to the consensus on channels like Appliance Tech Matt, is to replace the machine. Not because repair is impossible in theory, because the repair cost exceeds 50% of replacement cost, which is the rational economic threshold for writing off the appliance. So you replace the machine. You buy another smart washer because that is what every store sells. You are now 18 months into a replacement cycle that will run 3 to 5 units in the time your grandfather ran one. The board itself is also serialized to the machine's firmware. If you find a third-party CCU on the aftermarket, the AliExpress clones that run $50 to $100, there is a documented risk that the replacement board creates new error codes because it does not carry the original machine's calibration data. Proprietary firmware recognizes OEM components versus aftermarket components and responds accordingly. The manufacturer's preferred outcome is that you do not repair at all. They want you to call a technician, get quoted $400, and walk into a showroom. They want you to read the warranty disclosure, find the binding arbitration clause, and decide the lawsuit is not worth your time. They want you to absorb the loss, chalk it up to bad luck, and buy again. This is not a conspiracy. This is a documented business model with a 15% appliance margin target on the earnings report. But here's the thing. If the entire market appears to be running the same playbook, that does not mean you are out of options. It means you need to stop shopping like a consumer and start thinking like an auditor. The first and most important alternative is Speed Queen. This is not a sponsored mention. It is an engineering fact. Speed Queen is manufactured by Alliance Laundry Systems in Ripon, Wisconsin. Their residential top-load washers are built around simplified electronic controls with rotary knobs. No app integration, no Wi-Fi module, no capacitive sensor array. The control architecture is dramatically simpler than anything Samsung or LG produces. Their commercial-grade stainless steel tub is heavier than any residential unit on the market. Their transmission is a gear-driven assembly designed for commercial laundromat use. Speed Queen has recorded 0 recalls from 2016 through 2026. 0. Samsung recorded multiple major recall actions in the same period. The Speed Queen TC5 top-load washer retails around $1,500. That price will stop a lot of people. Do not let it. Run the math over 10 years. A smart washer at $1,000 plus one major repair at $500 plus one replacement unit at $1,000. You are at $2,500 over a decade. The Speed Queen costs $1,500 once. Repairs over the same decade average $100 to $200 in small mechanical parts. You come out ahead, and you do not spend a single afternoon in an appliance showroom wondering why your 2-year-old machine is already dead. The second path is the commercial-grade used market. Pre-2008 top-load washers, specifically the Whirlpool and Maytag machines built before consolidation degraded Maytag manufacturing quality, can be found at estate sales and used appliance dealers for $200 to $400. These machines have mechanical timers. They have belt-driven or direct-drive mechanical transmissions. Every part is available, every repair is field serviceable, and the machines in good condition will run another 10 years minimum. A used Maytag heavy-duty series or a pre-acquisition Whirlpool top-load from the late 90s or early 2000s is a better machine in every engineering dimension than anything on a showroom floor today. If you need a front loader for specific reasons, HE detergent, a stacked unit, look at the Speed Queen FF7 front load washer. It carries the same commercial-grade construction as the top load line. Repair manuals are publicly available. Parts are sold openly. The company has not placed a single software lock on a component. When you walk into an appliance store, here is what you are auditing. Ask the salesperson, does this machine have a central control unit that integrates the motor drive, the water sensors, and the Wi-Fi in a single board? If the answer is yes, walk away. Ask whether individual sensors can be replaced without replacing the board assembly. If the answer is no, walk away. Ask whether independent repair technicians can access diagnostic codes without a manufacturer subscription. If the answer is no, walk away. You are not looking for a smart machine. You are looking for a durable one. Those are not the same thing. In 2025, they are opposites. There is one more thing to understand before you make your next purchase. What happened to the washing machine did not happen by accident. And it did not happen because engineers forgot how to build durable things. Durable mechanical appliances were replaced because they lasted too long. They lasted so long that replacement demand could not sustain the revenue models that Wall Street was demanding. The solution was not to make them fail fast or visibly. That would be too obvious. The solution was to embed failure into complexity. Every additional sensor is another failure point. Every Wi-Fi module is a component with a firmware expiration date. Every software integration is a dependency that the manufacturer controls and can discontinue. They took a 25-year appliance and engineered it down to 5 years without ever stating that intention in writing. Whirlpool's own SEC10K filing uses the phrase value engineering to describe the process that delivered a 12% appliance segment margin. Value engineering is their term. The correct term is margin extraction through accelerated obsolescence. Every dollar they remove from the mechanical core of that machine is a dollar you will spend at a repair shop or a showroom inside of 5 years. This is the calculation they made. This is the calculation you need to make in response. Stop buying complexity. Start buying physics. Stop trusting the smart label. Start reading the repairability score. Stop replacing machines every 3 years. Start owning one machine for 20. Buy the Speed Queen. Find the pre-acquisition Maytag. Learn to replace a belt and a pump seal before you hand $400 to a technician who is going to tell you the machine is not worth saving. The machine your grandfather bought was worth saving. It was built to be worth saving. Yours was built to the opposite specification, and the people who built it knew exactly what they were doing. A machine that lasts 20 years is an asset. A machine that lasts 3 years is a subscription you never agreed to sign. Refuse the subscription. Own the asset. And do not let them sell you a Wi-Fi connection as a substitute for a gear.